yesterday I think we decided that now we should update our classes, whatever we have written so far, and to use the, for example, that forEach, and writing forEach as a method. Some of the places use the method reference, fine, at some of where it is possible. And other was, since we have seen how simple it is to create comparators, right? So now let's create comparators in this manner. Right? Okay, so we would like to update our code, whatever we have written so far. Okay, and so let's do that. Yeah. Okay, so let's start with the account class. What are the changes, where they are coming? Okay, let's check this. Yeah. And so these changes may not have a effect in the output which we are getting. Okay. It's only that how it is done that's being changed. Okay. Fine. We have this method called print passbook. Yeah. Oh, we have written a for each, right? There's a for each loop. Okay. Fine. So can we change this to use a for each method, right? Because this, again, we can see passbook is a list. Fine. So it is iterable, and therefore it has a method called forEach. Okay. Fine. So the change could have been here, which can be done here is something like this. Instead of using the for loop in this manner, okay, we can, yeah. Okay, let's comment this out again. Okay, yeah, another comment here. That's better. Okay, and then let's rewrite this thing. So how it can be done? This dot passbook, right, dot for each. Okay, and then we have to write a consumer. Then the consumer will be given the object of transaction. Okay, so how do we write this consumer? Okay, it will be given an object of transaction. So given a transaction T, okay, fine. We are going to be writing a lambda expression here. Okay, what is it that we are doing? One of the things, if you look at this code here in the earlier version, then it was this, right? The first thing we do is there are at least two statements. So there's no question of a method reference here. Okay. So one is about updating the running balance. Okay. What is the running balance? It's a local variable. You can see it's a local variable in this method. Okay. Is it a final or effectively final? We have set an initial value and then we are even updating it, right? So is it final or it's not? It's not a final variable. Therefore, if I try to use this statement, if I try updating this within my lambda expression, right? Within the lambda expression, if I have to update. So here, because since I have more than one statement, yes, I would be writing something like this. This is what was expected, that there will be two statements. One will be the statement to update the running balance, right? Okay, let me just copy and okay. So these were the two statements which we would have needed here. Yeah. Okay. So this is the printf and this one is the updation of running balance. But then yes, if I try this, what will happen? Right, it will be an error because of using running balance. effectively final. So we can't change running balance to final. It's required to be updated. Fine. So there is a workaround. Okay. So if you are finding such a thing, okay, it's not a recommended thing, but yes, in some cases, if you feel, yes, you can always make this kind of a what's the way, fine, how to work around this error so that we don't get the error of it's not being final or effectively final. Fine. What can be done here is this variable which we have declared here, running balance, okay, so that could be changed to an array. We make it an array type, okay, with one element. So it's an array with one element. Okay, so now that element is updatable. The reference to running balance is not changing. This variable which I'm trying to use is not going to change. I'm not saying running balance equal to something now. Okay, I'll show what the point is here. Okay, the point is I'm not updating running balance equal to something. I'm just making running balance of 0 plus equal to t dot get amount. So I'm not updating running balance. Running balance is a reference to an array. So that is not being updated. You're not changing it to a different object. Okay. Fine. So then this should work. Of course, we'll have to change at one more place here. Okay. It's running balance of 0. So running balance is now a effectively final variable. Fine. So this is a workaround. Fine. Okay. Fine. We can compile and check this code also. Right. So this is what we have done is we have used the forEach method. Right, when a consumer has been given as a parameter. The consumer is for a transaction, it's a consumer of transaction. So given a transaction, yes, what it does is updates the running balance 0th element, right? And then, yeah, does the printf. So the passbook can be printed. Okay. And so that's the first change we have done. Okay, I want to compile and check the code. Okay. Let's compile. This will be bank account.java. Okay, so that's compiling. And we can simply run the code. Test. Okay, so print passbook, there's no change in that, and the output is still working. Okay, fine. Let's just go through this code again. Is there anything else that can be changed? There is this class transaction. Okay. Fine. List.copy of. We have used the static method copy of to return an unmodifiable list. Okay. Yeah. Okay. That's our account constructor. Comparison logic doesn't change. Equals hash code. Deposit method, withdraw method, I think, yeah. So this particular file is okay now, I think, fine. So we have updated this one. Okay, fine. So change to the account. Let's go to bank. If there is any change anywhere which is needed. And you have this create method. Open account. There is not much change. There will be changes which will be in the test account class where the comparator is being created. Okay. Okay. I think in list accounts, yes, we have one change where we may be able to use the method reference. Yeah, I had written this code already. So fine, the idea is instead of using a lambda expression like this, we may use the method reference. Fine. Given an account, call the display method. Fine. So that's changed to a method reference now. I think, yeah. So bank also fine. Now let's look at the test account. Yes. Fine. So here, what we have done is we have been using the sort method where we have created a comparator by using, yeah, the comparator is new comparator. Here we have used the inner class. Okay, this is where we have used inner class. Some other places I think we might have used the lambda expression. Okay, let's look at it from the beginning. So it's mainly about the comparator now. Okay. So creation of array was here. Now it is arrays.sort, comparator.nulls first, and then we have said comparator.natural order. Okay, so there's no change in this place. Here is the other sort, reversed, and we have even used the method reversed. Yeah, here we have used a lambda expression, right? Okay, so this can be changed, right? This can be changed now. So instead of doing like this, okay, so we can say name comparator. So let's comment the earlier code. Okay, name comparator equal to, and no, we don't need the, we want it to be compared by the getName method. Okay, fine. So we'll just say comparator dot comparing string. GetName returns a string which is comparable already. Okay, so comparator dot comparing, and here it will be, okay, I think let me take this into the next line. Just simple. But a function which returns a name. So comparator, yeah, this one will create a comparator. This is how you create a comparator. You want a comparator to compare by name. Fine. It's a comparator for the account. Account has a method to get the name. Okay. Just specify that method. Fine. So creating comparator is much simple now. Okay, fine. Creating a comparator in this case, again, oh, it's our balance comparator. Same thing here, right? Okay, so we have a, this we can comment. Let me create a copy first. So balance comparator equal to, no, we don't want to use the lambda now. It has to be based on the balances, and so we just have to specify the comparator dot comparing long. Fine. Balance is of type long, so we'll say comparing long. Fine. And this will be account colon colon get balance. Okay. And so comparator which compares by balance. And so realize how simple now it has become. Okay. Same way, even this one. Okay. Now in this case, we have used the compare to ignore case. Right? But we have a knowledge that there is one comparator for string which compares based on the case insensitive, right? So here we will have to use the overloaded form of the comparator. Okay, name comparator 2, we'll comment this out. And name comparator 2 is not using a lambda. Okay, fine. Instead it says comparator dot, it is still comparing method, but now it will have two parameters. First is a function, yes, it is the name parameter which I want to compare. Okay, so it will be account colon colon get name. Okay, the second parameter is the comparator object which will compare strings by ignoring the case. Okay, so comparing strings by ignoring the case, for that in the string class we have the, okay, so let me keep it in second line here. In the string class we have the comparator as a, so this is a case underscore insensitive order. Okay, so that's a, basically this is nothing but in the string class there is a static variable called case insensitive order. Okay, the type is comparator of string. Okay, it's a static member of the string class. So we have used this. Okay, and so we're not changing the output, whatever is the way it is working. Only thing is, and the way we have written the code for creating comparator, okay, that's what is being changed. Okay, this one was a change which we had done to demonstrate how the inner class can be used for creating a comparator. So this is anyway a repeat of what was done earlier. Okay, anyway, so let this be remaining. Okay, and we are not changing it. Okay, anonymous classes. Okay, so it's like example of using anonymous class for creating a comparator. Okay, fine. So only for that reason I have left it. Okay, otherwise yes, this is not the way we would do it. Okay, fine. It's just been left out here. Okay, to keep one example. Yeah. Okay. Again, oh, here we have done this. At the end we have done a for loop. Okay, fine. We might change this also. Fine. we want to print passbook for all the accounts, and that can be done by saying accounts dot. Okay, accounts is an array, right? So from an array, how will you print the? How will you use the forEach as a method? No, it's not available on array. Okay, fine. But there is something what you can do here. Okay, I'll use a static method of the arrays class. Arrays dot as list. It converts an array into a list. So you get a list. Now this list which you get, okay, we saw that we have this method, static method in list, which was a copy of method to create a copy from any collection. Right? That list is unmodifiable, right? This list which you get with the use of as list, okay, as list, and you can give the accounts object. So this returns a list object, but this list is not that it is not modified. It's not an unmodifiable list you are getting here. Okay, the list which you are getting is slightly unmodifiable in the sense, partially unmodifiable in the sense the size cannot be changed. You cannot be deleting or adding a new element, but you can set, you know, the set method available in the list, that would work. Okay, because underlying thing is an array. The size of array cannot be changed. Okay, and so this list which you are getting with the help of arrays dot as list, okay, this is a list which cannot be resized. No addition, no add or remove working on this list. Okay, but get set is working. Get anyway would work, but set is still working there. Okay, you can replace elements in this list.
So the change in this would be reflected in array as well.
Yes, it's updating in the array.
Whereas in that case it was not.
No, that was a separate copy. Okay, it's now giving it to you as a list. So it's creating a list which is actually working on an array. Implementation of list which works on the underlying array. Yes. Fine. So this is one way. So then you can this dot for each. Okay, just to get that for each thing working. Okay, and you can just say account colon colon print passbook. Okay, and so that's the way we can print passbook for everyone. Okay, so if it's an array, yes, arrays can be converted to a list. Right? Later we'll be looking at another one. This for each method is also available in the streams. Okay, so we normally convert an array into a stream and then use the method like for each. Okay, so yeah, that change can be done when we look at the streams. And so I think we are done with the changes related to the. Let's test it. Okay, Acha, we have to test the test account class. We have the test bank also. Okay, fine. Test dot test account. Yeah. Okay, I think there's no change in the output. So yeah, we were anyway not intending any changes in the output. Yeah, there was some try catch which we had done, and anyway, so there's no change in this output. Okay. And our change was not for any change in the output. It was only that we wanted to use the methods like for each. We wanted to create comparator using a much simpler way. We saw it's now very simple to create a comparator. Fine. Again, we can have one more example of a comparator here. Okay. So that we use the other method of comparator. Where is that comparator? The last comparator we have created. Okay, arrays dot sort, name comparator, balance comparator. Okay, so we got lot many comparators. Let's create one more comparator. Okay, this is the last arrays dot sort which was done. Okay, so here at the end, let's create another comparator of account. Okay, first balance and then on name. Okay, let's observe the output which is coming first, and then we can decide what to do, right? Let's see. How's the output? The last one sorted was after sorting by name. Okay, so name is fine. Are there any with the same balance? Two of them with the same balance? No. Okay, so we might have some transaction where two of them will have the same balance. Okay, let's, this is 49,000 and this is 5,000. Okay, so 5,000, if we add, how much is to be added to make it 49? Let's, so 44,000, right? So savings account 1001. Okay, yeah. Okay, which is that one? We had that AC1, AC2. AC2, I think so. It's AC2, I think. So that's one thing which we can do. Okay, so we'll create a comparator first. Let's do that. Okay, so AC2.deposit, and we can deposit 44,000. And this comparator is our balance, then name. Okay, is equal to comparator dot, oh, instead of saying it's not static method now, it's we have our comparator for balance, so we have the balance comparator dot then comparing name comparator. Okay, so we can do like this also. Fine, and then we would like to use it. Okay, so first array dot sort, this is, oh, we want to now use the sort method. after sorting by name case sensitive. Okay. Okay. Arrays dot sort accounts comma then name. Okay. And so this is sorting, and then we have to print it after sorting. Okay, let's check this. Fine, we'll check this now. Test account. So when we run the okay, so this is after okay, sorting by balance and name. So it is first sorted on balance. So 49. Oh, 49 hasn't changed. But there are two with 49, right? And is it sorted by name? James comes before Josh. Okay. Okay. And then the other balances are higher, right? It's sorted on balance. We can see that. Fine. But where balance was same, it has used the name.
First balance was used.
First balance and then the name.
And because both J's were equal, then
Yes.
second letter was taken, B and O.
Huh. Okay. So our comparator, fine, we know how to combine comparators when we have multiple keys. It's like, first key is balance and then the second key is name in this case. So there are multiple fields to be used for ordering, and we can order by the more than one fields.